Okay guys, so now I'm going to go ahead and go over the worksheet with you all. You still have the video if you need extra resource for any of the things we talked about today. You have lots of graph papers, so I think it's helpful to graph and to show your shape sometimes, to use both methods, modeling as well as mathematically. So as we go over the worksheet, we'll stop after each problem and we'll graph it and model it and in 3D space, and use your graph paper, basically each square as one unit of measurement. And so most of you did really well with that. When I walked around, you got to go around in other groups as well to see how they were doing. So we first ask, volume is what? It's the measure of what that occupies a solid region, and it's basically the measure of space, or the measure of what fills that space. So I gave you the formula, and most of you are pretty quick to also know this because we talked about area last class. The formula for volume was length times width times height. So instead of dealing with something that is in 2 dimensions, now we have 3-dimensional space that we're going to measure. And the difference now is we have a new measurement, and that measurement is volume. So whenever we measure volume, because we're multiplying 3 numbers, we're also multiplying 3 units. So the units will also get measured, multiplied together. And that's where we get the cubic unit from, that Zachary was very quick to mention at the beginning of class, which was our objective for the day. So if we look at number 1, we have, excuse me, we have a length of 7 inches. We have a width of 2 inches and a height of 4 inches. So we end up with 56 inches cubed. So now let's go to our graph paper. Let's see if I have a clean piece. I do. Okay. And for our length, we want to go 7 units. So we're going to count our units: 1, 2, 3, 4, 5, 6, and 7. Graph paper is really nice because you can count it as your unit, or your each square is a unit of space, whereas you can also use your ruler to exactly measure the amount of inches, centimeters, or meters for dimensions of prisms. So we also said we had a height of 4, so we're going to go up 4 units. And then it goes out into space 2 units. So you're able to calculate, and you're able to use modeling as an example, as a way to example what you're looking at as well. Let's look at the second one. Drawing 3D is kind of hard, but graph paper does help a little bit. We have 4 centimeters for the length. We have 5 centimeters for the width. And for the height, that is also 4 centimeters. So we end up with 80 centimeters cubed. Aiden, why don't you show us the graph that you did for number 2? Yeah, you can go ahead and model it on the backboard for us. Thanks. Exactly, that looks great. Thank you. So again, even without graph paper, he was pretty quick to give us a nice 3D prism with a width of 5 centimeters, a height of 4, and a length of 4. And we can see our shape, and now we're able to calculate and see where these units come from. We have 3 units of space that we measure, 3 units of space that we multiply, so all of our units are going to be cubic units, whether it's inches, centimeters, or meters. Number 3 is just worded in a word problem. It's no different than having it in a modeled visual like number 1 and 2. So if we look at number 3, it says find the volume of a fish tank that is 8 feet long, 5 feet wide, and has a height of 5 feet. So again, no different. We have 8 feet for the length times 5 feet for the width, and then for the height is also 5 feet. So that's going to equal 200 cubic feet, or 200 feet cubed. So let's go ahead and on your graph paper 2, we can model that one. So you want to go 5 units, and then it was 8 units across, correct? Yes, 8 units long. And it goes into space, or it has a depth of 5 units as well. Awesome. So I have some homework that I assigned for you guys as well to work on. I think that will help you guys a little bit with volume. After we talk about volume, we're going to move forward and start talking about density and how volume connects, like I said, to other units and to other measurements. We started with area, we moved forward to volume, and now we'll see how volume can connect with the density. Again, the unit tells you so much about what you're talking about. When I tell you something is 16 meters squared, immediately you know that unit is going to relate to the measurement of area, because the unit tells you what you're measuring. Whenever I say 13 inches cubed, right away you know it's what? Yes, exactly, that it's volume, because volume always has measurements that are cubed. When we first started measuring in linear, just one line, we had one line, so we had one dimension of space. So if we measured something, it was 1 inch, 1 meter, 6 inches. So now we're doing multiple dimensions, so we're going to have multiple units that go along with those numbers as well. And those units identify a lot about what the number represents. So it's really important to start to justify units and understand what they mean and how they connect to a lot of other things. And yeah, being able to use different types of measurements to understand